Sometimes solving an equation involves more than one step. We'll see that in this example. 4x minus 5 equals 3x. Well, again, I have x's showing up on both sides of the equation. So to get x isolated, I need x all by itself on one side, so I need to get rid of it on the other side. I'll subtract 3x, and the 3x on the right will go away. So 4x minus 5 minus 3x equals 3x minus 3x. I've just taken my original equation and subtracted 3x on each side. If I subtract 3x on the left, I also have to subtract 3x on the right. Now what does that leave me with? On the left side, I have a 4x and a minus 3x. That leaves me with an x on the left, but I also still have this minus 5 sitting here. So on the left, I have x minus 5. On the right, I have 3x minus 3x, which is just 0. So now my equation is x minus 5 equals 0. X is still not isolated. X isn't all by itself over here. To get x all by itself, I need to get rid of this minus 5 that is stuck onto it right here. I can get rid of that by adding 5. If I were to add 5 to the left side, I would have x minus 5 plus 5, and the minus 5 and the plus 5 would cancel each other out. If I add 5 on the left, I also add 5 on the right. And this is often done, instead of rewriting it like this, x minus 5 plus 5 equals 0 plus 5. Instead of rewriting all of that, what's very common and a lot quicker is just to write in the plus 5 on each side. So I'll just write plus 5 over here on the left and plus 5 over here on the right. So now I read the left side like this: x minus 5 plus 5. And the right side is 0 plus 5. And now I can see that on the left, the minus 5 and the plus 5 cancel out, leaving me with x. And on the right side, I have 0 plus 5, which is 5. So the equation is solved. X equals 5. Now let me just reiterate this point. The examples we've been looking at have involved starting with an x on each side. And our goal is to get our x simply on one side. Choosing just the right thing to add or subtract helps us get rid of all the x's on one side, leaving them entirely on the other side. Here's another example. 6x plus 7 equals 5x. I'll start by subtracting 5x from each side. So the left side is 6x plus 7 minus 5x. The right side is 5x minus 5x. I've done the same thing to each side. Put a minus 5x on each side. On the left side, I have my 6x and my minus 5x, which just adds up to 1x, and I still have my plus 7. So x plus 7 equals, on the right side, 5x minus 5x is 0. So x plus 7 equals 0. Then I can subtract 7 from each side. And on the left, the plus 7 and the minus 7 cancel out, leaving me with x. It's now isolated. And on the right side, I have 0 minus 7, which is negative 7. So that's my solution. X equals negative 7. This example has a variable, you see x right there, on each side, and a number on each side. We can still deal with that. It's not a problem. I'll start by subtracting 7x from each side. That will get rid of the 7x on the right, and all my x will be on the left at that point. So I'll write 8x plus 4 minus 7x on the left equals 7x plus 9. I also subtract 7x on the right. Again, and I'll emphasize this point over and over, you have to do exactly the same thing to each side. On the right now, you can see the 7x and the minus 7x add up to 0, so it's as if they weren't there. I can cross them out. And on the right side, I just have 9. On the left, I have a 8x and a minus 7x, those are like terms. They're both x terms, so I can combine them, and I'm just left with x. And I still have the plus 4. So x plus 4 equals 9. Now I can subtract 4 from each side. That gets rid of the 4 on the left, leaving x isolated. X is equal to, over here I have 9 minus 4, which is 5.